So, hello everyone, and welcome to this session aimed at showing how to create a landscape report, a patent landscape report, by means of the help of Microsoft Power BI. We have already seen certain applications regarding, for example, the visualization of technology trends and of visualization of the strategy of certain competitors. So showing how they file patent applications to different authorities. So today we will integrate this information, in particular focusing on the production of geographic maps, which are aimed at showing the distribution of patent applications over time and considering different patent authorities, so different territories. And so, as usually, I'm going to share my screen and to show you how we can obtain a patent landscape report. So, in particular, this page, named Applications per Territory, shows in the upper part a bar diagram which shows the distribution over time of the patent applications. While in the bottom part, we have a geographic map showing the same information, but with a higher granularity level, because single patent authorities, so single countries, and therefore single territories which can be appealing as market, are shown. We have in the middle part several slicers, for example, one dedicated to the possibility of selecting different patent authorities, one by one or more than one simultaneously. And then we have a slicer dedicated to the selection of the earliest filing year. So in order to select, for example, the patent application that have been filed for the first time during a certain year. And we have filters that allows, by means of bookmarks, to restrict the visualization of the information to specific authorities. For example, typically to the patent applications filed to the European Patent Office rather than the World Intellectual Property Organization, because these two data are not visible from the geographic map. And so, for example, if one selects from the slicer dedicated to the patent authorities EP, which means EPO, one just sees the distribution of the patent application over time, but of course, there is no representation on the geographic map. And the same is true for the applications filed to the World Intellectual Property Organization. Then we have another page in which we can rank the top players, in this case concerning the next generation sequencing of nucleic acids, so very recently introduced techniques. And as we have already discussed, there is the possibility to select one by one or more than one player in order to focus on the patent applications, or better, the number of patent families owned by that specific player. We have already discussed about the creation of a dashboard showing the protection strategies from different players. So in this case, there is one which is rather famous, and the patent applications filed from this player are evidenced by means of a ring diagram, which is a rather classical visualization. But the same information with a higher granularity level can be displayed by means of a Sankey diagram. So here we have the same applicant with different denominations, so different subsidiaries belonging to the same corporate, and we can see the number of inventions, so the simple patent families, and the authorities listed on the right to whom the different patent applications have been filed over time. Our patent landscape report is completed by means of dashboards dedicated to the clustering of patent families depending on specific patterns of IPC classification codes. So this is a way to produce cluster of patent documents sharing identical or very similar technologies. And eventually we have dashboards dedicated to the technology trend, like in this case, still referring to next generation sequencing, in which the distribution of patent families to whom specific classification codes or combination of IPC classification codes are assigned can be visualized at a relatively broad view or at a rather detailed level, like for example, in these three cases, dedicated to three specific classification codes, in particular dealing with the, sequencing technologies aimed at sequencing nucleic acids. For example, we have the C12N subclass with this distribution. Then we have, for example, another important classification code corresponding to the subclass C12Q. And the third subclass that we have included along with the former two in our search query is the G06F. And in this case, it's interesting to notice that after year 2018, this classification code has been no longer assigned at least in a significant manner. Whereas the very last dashboard is dedicated to another classification code characterized by the subclass C40b that we have not included in our search query, but emerged from the analysis of the dataset as another important classification code as far as sequencing technologies are depending or on combinatorial methodologies aimed at sequencing of nucleic acids. And having shown this dashboard now, I just switch off this application and we just need to try to reproduce the data, in particular regarding the production of the geographic map that we have shown in the first dashboard. So I have created a new file named exercise that I'm going to open. The application requires a few seconds to appear. Okay. So in this case, what we need to do let's remove also this. In this case, what we need to do is simply to import data that concern the information regarding the patent applications, the patent families, the applications authorities, and the earliest filing year. And we can find, let me search the folder. Okay, here we go. Okay, here it is. NGS filing events. I open this file. And as you can see, when I open filings, I get the fields, the attributes which refer exactly to the information I need to analyze. So I simply say load, and it takes a few seconds to import this data. That's fine. Now, in order to create a geographic map, I need to import another dataset, which refers to the denominations of the countries, considering that there is an abbreviation, usually by means of codes consisting of two letters. So in order to let Power BI work properly, managing these codes, these country codes, what I need to do is to import from the web a page from Wikipedia, whose link I just simply copy and paste in this window, and I press OK. Okay, now before connecting the two tables, I need to import from this link the proper table. And so I say load. And having said that, I just want to visualize this data as a table. And in correspondence of this column in particular, I just need to rename the category of this data, which correspond to a country. Then I switch again to the visualization of data in graphical format, or rather, I just switch to the tables in order to make a connection between application authority and alpha2 code, which originates an interaction between the two tables based on a one-to-many relationship. And now we are done, because here I just press the map visualization tool. Sorry. Okay. So in the location, I simply include the names of the countries based on alpha3 code. In the legend, for example, I can import the earliest filing here from the filings table. And as far as the bubble size is concerned, I just want to determine the number of patent applications filed to the different authorities. I need to count distinct patent applications, so in order to exclude duplications of the same data. And here I got my geographic map. So if I want to enrich this information, as we have seen earlier, I can put, for example, I can add a bar diagram showing the same information, evidencing the trend over time. So on the horizontal axis, I add the earliest filing year. And on the vertical axis, I again include the application ID values. In other words, the patent applications filed during each year. Again, count distinct. And if I want to make the picture more clear, I can add data labels, switching on. And I can show them, for example, correspondingly to each and every bar. The values are displayed in a color that I choose to change. For example, this one can fit our need. And perhaps we can enlarge a little bit the font to have better evidence of our data. Fine, then I can include some slicers, as we have seen previously. One specifically dealing with the patent authorities, so I just include in the field application authority, which is automatically displayed in form of vertical list. And then To conclude, we create another slicer that allows us to select the different values of the earliest filing year. In this case, we need to modify a little bit the slicer settings. So we switch from the between to vertical list. And to conclude with, we can also add a card, for example, something like this, in which we can count non-duplicated number of patent applications, so count distinct. And so this tells us that we have in total 4,151 patent applications, considering the whole number of patent authorities. For example, if we switch to China, you see that the number changes accordingly. And so also in the case of the EPO, although we cannot visualize the values displayed on the map, we can argue that we are dealing with 271 patent applications, and the distribution of these 271 patent applications over time is shown by the bar diagram. And so this concludes our exploration of Microsoft Power BI. Thank you very much for the attention.